Welcome back to Sex Education Repo, where we explore the fascinating world of human evolution and biology. Today, we're diving into a question that has puzzled scientists for decades. Why do human females live so long past their reproductive years? It's a genuine evolutionary mystery. From a purely biological standpoint, an organism's primary purpose is to pass on its genes. Once that ability ceases, natural selection typically doesn't favor a long post-reproductive life. Yet, humans are a remarkable exception. We are one of only a handful of species on the entire planet where females experience menopause and then continue to live for many more decades. This phenomenon isn't just a quirk, it's a defining feature of our species. Think about it, most animals reproduce until the very end of their lives. But for human females, a significant portion of their lifespan, often a third or even more, is spent in a post-reproductive state. For a long time, evolutionary biologists struggled to explain this. Why would evolution select for a trait that seemingly offers no direct reproductive advantage? The answer, it turns out, might lie not in the women themselves, but in their grandchildren. This brings us to a captivating and elegant explanation known as the grandmother hypothesis. It proposes that menopause isn't an ending, but rather a strategic evolutionary shift. The core idea is that as a woman ages, continuing to have her own children becomes riskier, both for her and for the baby. Childbirth has always been a dangerous endeavor, and these risks increase with age. At the same time, her existing children start having their own families. This presents a new, and arguably more effective, way for her to ensure the survival of her genetic legacy. Instead of investing energy and resources into having another child of her own, who might not survive, she can redirect that energy toward helping her daughters and their children thrive. A grandmother's wisdom, experience, and support become an invaluable asset. Imagine our early human ancestors living in small, tight-knit groups on the savannah. Life was incredibly tough. Finding food, avoiding predators, and raising children to adulthood were monumental challenges. In this environment, a knowledgeable and helpful grandmother could make the difference between life and death for her grandchildren. She could help with foraging, gathering nutritious roots and tubers that a younger, nursing mother might not have the time or energy to find. She could also provide crucial childcare. By looking after the toddlers and weaned children, she would free up her own daughters to focus on having more babies sooner and to dedicate more energy to caring for their newborns. This creates a powerful ripple effect. A daughter who has her mother's help can have children more frequently and successfully raise more of them to adulthood. This directly increases the grandmother's number of descendants, ensuring her genes are passed on more effectively than if she had continued to reproduce herself. The grandmother hypothesis was first proposed by biologist George C. Williams in 1957, but it was anthropologist Kristen Hawkes who truly brought it to the forefront with her extensive research. Hawkes and her team studied the Hadza people, a modern hunter-gatherer group in Tanzania. Their way of life offers a glimpse into the conditions our ancestors might have faced for millennia. What they observed was remarkable. They found that the most difficult food to acquire, but one of the most reliable and nutritious, was underground tubers. It takes a lot of skill and strength to dig them up. Young children couldn't do it, and nursing mothers were often too busy or lacked the energy. But the postmenopausal grandmothers? They were the champions of tuber foraging. These older women worked tirelessly, digging up far more food than they could eat themselves. The surplus was then shared with their daughters and, most importantly, with their grandchildren who were just past weaning. This extra food was a game changer. It provided a critical nutritional buffer for the young, vulnerable children, significantly boosting their chances of survival. Children with a dedicated, foraging grandmother were better nourished and healthier. This direct support allowed mothers to wean their children earlier, which in turn shortened the time between births. More babies, who were more likely to survive, meant a huge evolutionary advantage for that family line. The data was clear: the presence of an active grandmother had a profound, positive impact on her grandchildren's survival and her daughter's fertility. Evolution, it seems, had found a better way for older females to contribute to their genetic legacy. This shift in focus, from mothering to grandmothering, is what the hypothesis suggests drove the evolution of menopause and a long post-reproductive lifespan. Natural selection favored women who stopped reproducing and started helping. Over generations, the genes for a longer lifespan and the cessation of ovulation around midlife would have become more and more common in the human population, because the women who carried them left behind more surviving descendants. This isn't just a story about food, though. A grandmother's contribution extends far beyond just providing calories. She is a living repository of knowledge and skills. She knows the land, the seasons, and the subtle cues of nature. She holds the social knowledge of the group, understanding complex family ties and alliances. She is a teacher, a caregiver, and a source of stability. This transfer of cultural and practical knowledge is just as vital as the transfer of genes. It's how humans build upon the successes of the past, generation after generation. Grandmothers were, and still are, the keepers of this crucial wisdom. This hypothesis also helps explain why humans have such a uniquely long childhood compared to other primates. Our large brains require a tremendous amount of energy and a long time to develop. Having grandmothers around to help provision for these energetically expensive children makes this extended developmental period possible. Without them, it would have been much harder for our species to evolve the complex brains that define us. So, when we look at menopause, we shouldn't see it as a biological failure or a decline. The grandmother hypothesis reframes it as a powerful and uniquely human evolutionary adaptation. It's a testament to the importance of cooperation, family, and intergenerational support in the story of our survival. It highlights that a person's value to their community and their lineage is not limited to their ability to reproduce. The wisdom, care, and support of older generations have been the secret key that allowed humanity to not just survive, but to flourish in a challenging world. The love and labor of grandmothers are literally woven into our evolutionary DNA. Thank you for joining us on Sex Education Repo. If you found this exploration of the grandmother hypothesis as fascinating as we do, please consider subscribing to the channel for more deep dives into the science of human life. We'll see you next time.